So in this video we're going to define the determinant. So this is what's called a 2 by 2 matrix, and all a matrix is a way of encoding information. So a 2 by 2, what we would call square matrix, just holds 1, 2, 3, 4 items or elements in it, and these items or elements could be almost anything that we want. They could be vectors, they could be polynomials, they could be functions, they could be derivatives, they can be just normal real numbers. So it's just a way of encoding information. So for example, if I had a vector AB and a vector CD, this could be a matrix that is encoding the vector components in it. And if you have a matrix, and if addition and multiplication have been defined for the elements that you've stored in the matrix, then we define a determinant to be a calculation based on the matrix. So here notice I've got square brackets, and here I've got vertical bars, not brackets. So when you see vertical bars surrounding the elements in a matrix, you're being asked to calculate the determinant of the matrix. And the determinant by definition, this is called the main diagonal. So the determinant by definition is the product of the main diagonal elements minus the product of the other diagonals elements. This is how you define the determinant of a 2 by 2 matrix. If instead we have a 3 by 3 matrix, a 3 row by 3 column matrix, the determinant of a 3 by 3 matrix is defined like this. You take the first element in the first row, A, and you multiply it by, you scratch out the first row in the first column, and then you make the matrix from the remaining 4 elements, E, F, H, I. You make you calculate the determinant. You do A times the determinant of this little sub matrix, or what we would call the minor for A. Then you do minus, and then you take the second element in the first row, the B, you do minus B times, and then you scratch out that column and that row, and you make the minor for this element B, which is the matrix formed by the elements that are left. So we do DGFI, DGFI, and notice this is a determinant calculation here. And then you do plus C, the last element. You take C times, and then you cross out that row and column, and you take the little minor matrix DEGF that goes with C, the thing that's the elements that are left when you cross out C's row and column, and then you multiply C times that determinant. And then you just do the determinant calculation that we saw up here for a 2 by 2 matrix. We do A times parentheses, it's going to be E times I minus F times H, which is what you're seeing here. Then it's going to be B times D times I, right here, minus F times G, and then C times D times H, minus the E times G. So that's how the determinant of a 3 by 3 matrix. So they're fairly simple to calculate. So I could say, hey, let's calculate the determinant here. So this is just a determinant holding some integer values. So the determinant would be, so if I have 2, 1, 0, 1, 1, 0, negative 2, 0, 1, the determinant of this matrix is equal to, we do 2 times the matrix that's left when we cross out this column and this row. So we get 1, 0, 0, 1. Whoops, I put that in the wrong spot. I already had the bars going here. 1, 0, 0, 1. And then we do minus, always minus this term, minus 1 times the matrix we get when we cross out this row and this column. So 1, 0, 0, 1, 1, 0, 0, 1. And then we do plus negative 2 times the matrix we get when we cross out this row and this column. We get 1, 0, 1, 0, 1, 0, 1, 0. And then we have to continue to calculate or simplify. So it's going to be 2 times 1 is 1 minus 0 times 0 is 0, minus 1 times 1 is 1, minus 0 times 0 is 0. And then I have plus a minus, so this is going to be minus 2 times 1 times 0, minus 1 times 0. And finishing the calculation, we're going to get 2 times 1 minus 1 times 1 minus 2 times 0, so we're just going to get 2 minus 1 is 1 out of that. Here's another determinant. This one actually has the vectors I, j, and k. Remember, I is the vector 1, 0, 0. J is the vector 0, 1, 0. And k is the vector 0, 0, 1. So I have vectors in the first row, and I have just real number representations here. U1, U2, U3, V1, V1, V2, V3 just represent real numbers. So to calculate this determinant, we would take I times, we'd cross out I's row and column, and we would multiply by the determinant of what's left. So U2, V2, U3, V3, minus, and then we would do minus the vector j, times the determinant of what's left when you cross out the row and column corresponding to j, so U1, V1, and then U3 and V3, and then it would be plus the vector k times the determinant that's left when you cross out k's row and column. We get U1, V1, U2, V2, and then we would simplify the calculation here. This would be I times the product of the first of the main diagonal, so U2 times V3 minus U3 times V2 minus j times U1 V3 minus U3 times V1 plus k times U1 times V2 minus U2 times V1. This should be a parentheses. So as you can see, it's a fairly straightforward calculation. It's going to turn out that this is a calculation that's very useful, which is why it's getting defined.